Okay, all yours.
Hello, team. I'm Alfonso. I'm going to be talking about inversion of control. This is a design pattern, or I don't know if calling it a pattern is okay, but it's a way of coding things that will help you greatly on reducing complexity on the APIs of things. Well, it could be anything from a function to a component or React component, and also helping your clients, whereby the clients are the people using your code, to achieve things easily without really changing the base code. Okay. I just shared a code sandbox on Slack, in which I'm going to be explaining the basic gist of the pattern, and then we'll be trying to live code with your help Accordion, right? Which implements the inversion of control to make components that are I forgot the word. Give me 1 second. Compound components. Sorry. So composable components, which you can pass something like different pieces of different functionalities into a more global functionality, like an accordion. I'm going to explain it further on the talk, so we can explain that. So here we have the basic example of what inversion of control is and what, in which way it helps you. So let's think for a moment that the array filter doesn't exist on JavaScript, okay? And let's start implementing one from scratch, or pseudo scratch here. So remember, array.filter doesn't exist, so we have this, right? So our first implementation would be as simple as this one. Let me know if you can see the size of the words really well, because if not, I can, of course, zoom in. But this is the most basic filter, which you pass an array and it will create a new array in which all of the elements are the ones that are not null or not undefined, okay? So in the most basic way, it creates a new array, it iterates through the original array, and if we have an element that it's not the null nor undefined, we just append that into the new array, and in the end we return the new array. Okay, so here in the end we have an example of how it works, and here is the results of it. So as you can see, the undefined and the null are getting deleted, and we still have this one because we have this last comma here, right? So that's a basic filter, as a basic filter as you can get right now. Then I'm gonna be moving to the next file, which I have here. Okay, so let's say, okay, we have that filter, right? Then we try to pass options, which would be this object here, which enable the user to select some things, right? Like, for example, filter the null values, filter undefined values, filter zero values, filter empty string values, okay? What we will do here is mostly the same that we did previously, but instead of, well, adding the ones that just have like a null or undefined value out there, we check if the property on the options object is defined, and we then make the validation check for that specific case into the value. And then if all of these are false, we then add the new element to the array, so the element to the new array, and return the new array in the end. Okay, so this, it's mostly the same as we had previously, but now we have an option which we can pass, and it will work with those values, right? But let's say then our clients want to filter something for like when the value is an odd number. Okay, so if you want to filter when the value is an odd number, we will have to do something like odd number, filter odd number, and this will be by default, it will be false. We will have something like filter odd number. I don't know if that's filter the odd numbers or the even number, but I think it's the odd numbers. But if not, we can forget that and do the other thing. But we will have to add a new option, right? And it will create another another signature for the function, and so on and so forth. And of course, with the, let's say we will have to implement then the even number, then divisible by 3, then a string that starts with A, and so on and so forth. And we end with an options object that is immense and doesn't actually help our clients, because let's say our client wants to implement a filter that filter objects by, let's say that they are animals, and we have the animals like giraffe, elephant, seal, bird, or something like that. And we want to filter the ones that have wings. We'll do something like filter the animal dot wing equals true, and that, of course, you can implement it with something like this. I mean, you can, but it's really, really complex to do, and you don't. Probably it's a one case only use, right? So then we could change all of this and make this all a better filter function by using inversion of control. So let's go to the last implementation here. I have the index tree, which already has inversion of control implemented. But the idea here is that when you invert control, you are giving the control to the user of your library to do what they want on that specific place, right? So in this case, we want our client to be able to change the filter function as they like, right? So we have a new filter function that receives an array and a filter function, like a one item filter function. And with these new parameters, we can do something like iterate to the whole array and apply the filter function to each element. And if that function returns true, then we can add the element to the new array, and in the end, return the new array, right? With this, we could implement all of the previous defined functions that we had for filter and with any of the options that we had. But we also could do something like the weird thing that I explained, I tried to explain. So let's say we have this thing, right? So an animal have a name, which could be, I don't know, dog. How do you say? Oh, sorry. Okay. So let's say we have this. We have a cat, which also, we have a whale, which doesn't have name, right? So previously, if we wanted to filter this, we will have to add something here, like animal has legs. Ooh, and that could be a check that it's really complicated check, right? It's a really complicated check here. But with this thing, with this change, we will do something like filter animals, right? And we should pass a function here, which is element element of right? We can put this here, and I think this should work. It doesn't because why? Oh, okay. Yeah. There is another filter here which shouldn't be there. Sorry.
You wanted to make sure that it was filtering.
Yeah, and we have that, of course. Sorry. Because it's easier this way. Sorry for this. Oops.
You can use a console table and people see what is a console table. Without the error. Yeah, I think it should.
So there we have the filter being used as easily as creating I actually would do something like this because it's easier to understand. So we are using the same filter function and we can use it for everything that we want. Like we can have these animals, we can have this thing that filters and defines our nulls from the original array, and I don't know what there. So that's the idea behind inversion of control. You give the end user the ability to implement what they want on some pieces of your code. It doesn't need to be all of the code, because if it was all of the code, then why are you implementing these changes? But the idea here is that you can offer flexibility and some functionality that is global, but then flexibility for the specific cases, right? So that's what you have here. Of course, you could argue that in the end you have a worse API because you don't offer the same filter by, I don't know, odd number that we have here. But with these changes, you can implement a new function, which is, I'm gonna do the animal things. So you could do filter animal with legs. You give me a sec. Filter animals, and you can paste this here, right? What? Wait. Yeah, like that. So then you can use this one instead of this one. You have the same simple API that you had before, but for one element. And so you can recreate all of the filters that you had previously with this inversion of control filter. And that way, again, you reduce complexity for one side and offer flexibility for the other, right? So, well, this is the concept of inversion of control explained on the simplest function that I could get. Then, now we are going to move to React and inversion of control, which, as you can guess, includes componentization of components. I don't know if that's the correct word, but Like the main idea is you could use any you could pass components to another components to render some things, and we can then pass functions to that those other things, and so on and so forth. So I'm gonna share this new thing, this new code sandbox. Let me know if when you can see that and if you can see my screen. So for this one, I'm gonna explain the basic thing here, and then I'm gonna be asking you to offer some comments or what to do next, and we're gonna be doing some like interaction with you, right? Because well, the idea is here is that we all learn something, so that would be helpful, I think. So here we are going to be implementing this accordion that offers inversion of control to the user, and well, that's the idea. So I should probably prepare an accordion that was implemented with a non-inverted API, but I didn't because two things. One, if I did that, I would have to, well, we'll have to change so much code that the talk could be a bit long, and I didn't want that. And second of all, I think that explaining the solution actually does a better job than just changing the original, the non-inverted version to the an inverted version. So I think if you have questions, then you can ask me on the end or on Slack. But I'm gonna be showing only the inverted version of the accordion. So here, so this is the accordion that we have. I'm gonna be zooming because I think we can don't use this for the starting point. So this is an accordion implementation that offer inversion of control by small things. It's not that big of a inverted of control accordion, but I think that it just has the specific points that are needed to be really useful to use, right? And to have inversion. So it's an accordion, a functional component that has received 4 props. One is the state reducer, the on state change, open indexes, and children, right? So I'm going to be explaining which one does what, and why that part of it has inversion of control. Okay. So first of all, we have this state that saves the open indexes on this one, and we have this use effect to reflect changes made from the outside to the open indexes. That's nothing related to inversion of control. Then we have this internal set state, which what it does is it applies the changes. We are using a reducer, which it wasn't clear before. We have this state reducer that we are passing as a prop. So we have a reducer, and this internal set state, what this does is applies the reducer to the changes and then return a state. Okay. What we have here is we have the changes and a callback. Okay, and what it does is if the changes is a function, we apply the function to our state, which is only open indexes, right? And if not, we return the changes alone, right? And then we have this state reducer, which applies the changes to the changes object. Well, no, apply the changes object to the state. Sorry. So then, after all that's done, we have this. we save the new open indexes after we apply the state reducer to the changes. We call the function that we defined previously, and we call a callback. Okay, and this has inversion of control. Okay, where are we applying the inversion of control here? On the state reducer. As you can see, we have a default function for the state reducer, but on the future, we are going to be using this to create a new implementation or a new functionality for the accordion, right? I'm not going to be showing that right now, but here we have an accordion that can have multiple tabs open. We are going to be implementing something else on the future, right? And then we have this handle item click, which use the internal set state to. I had this here, but it isn't needed. This was converted from a previously functional component, class component into this functional component, and I left that there. Whatever. So here we are also using some kind of inversion of control, right? But it's not that specific. So what this does is it creates an action. So handle item click returns a type, which is opening or closing, depending if we are closing or opening the tab, and then returns the open indexes after we did that. Okay. So that's the accordion, and as you can see here, it doesn't really render anything. We only return the children's, and we pass the open indexes and handle it. Okay. So then we have the accordion item, which it really only uses framer motion to do things, and it doesn't have anything else really that is right now that is really complex for it, besides the usage of this open, which is something that we are passing an open handler, okay, which takes care of actually calling the function. And then I'm gonna be showing the basic accordion, which is the thing that you all have been waiting for, I guess. So here we have the basic accordion. The basic accordion, as you can see, has the accordion, which was this thing. Okay, and it uses also the accordion item here, which is each of these ones. And we have this. So we have this. This is the children that was defined or was required here. And then we have the prop signature that it was defined previously. So we have open indexes and handle item click. And both of them are getting passed into the accordion item, right? And we are also passing the actual index of the element. So what this does is we aren't using any of the inversion of control APIs that we wrote, because we don't need it for the basic accordion, because that's the basic functionality that we want to expose, right? So for example, this would be the filter that filters for the first filters that we built, the ones that filter from undefined and node. It would be something like that. Actually, if we want to really compare to the previous version, what we would do is something like this. So element, sorry. So if that were the same version, we implemented something that always doesn't filter at all. This is the basic version of the accordion, so it's the same thing. And well, that works as I was previously showing you, but then we could implement a single accordion, right? So a single accordion, it's something, it's pretty similar to a basic accordion, but the idea here is that only one can be open all the time. As you can see here, that's working fine. And with the inverted of control accordion that we built here, it's really easy to implement this one. So what you will do, it's something like passing a state reducer that is single, okay? And single, it's coming from chair, which is a new state reducer that we implemented, right? And that state reducer, it's implemented like this. So what the idea here is that our basic state reducer, what it does is it adds the last change to the open indexes, and with this single one, we only return the last one. So if we change, right here is the indexes are probably open indexes is an array of like this. Sorry. And when we add one, it ends up being this, but this is single state reducer changes to right that. Okay, so that's the idea of that state reducer in particular. So with that, we can build this simple single accordion that only opens one tab at a time. Okay. So what if we always wanted to have one open, right? We could pass this PreventClose, which is another state reducer that we could build. And it's these are the examples that I have for right now. But we could build something that only opens to, let's say, to the right, and we could still build that, right? So that's the idea here. That's the idea behind inversion of control, that you have a basic functionality that you want to expose, and you want to make sure that if your client wants to do something and the functionality is similar to what you have, then they could build it changing some things, right? So I'm going to show you the so I put this here. Now I'm making clicks here, and it does also close. But if I open another one, it will close, because you can have only you at least have to have one open. Right? And if you want to get really this. Okay, so, and if you have that, you can close that, and if you open the other one, it will open only a single one, right? So as you can see here, we used the state reducer to create multiple functional accordions that work similarly but are different, right? Because we implemented these 3 different state managements that comes from the state reducer. So another thing that you can change on this case with inversion of control is changing the accordion items. So you could, as I said, you could do something like opens on the right or opens on the bottom, right? And well, that's the idea here. I don't know. I said that I was going to be asking questions and doing that. I didn't, because I'm not used to do that when I'm talking, so I forgot. But please ask questions, and if you want to build something specific for this example, you can probably take control of the talk, and I can try to guide you, or we can try to all write it on the call. I don't know if anyone volunteers to do that. And if not, well, we can leave it as is, because I don't have more examples right now.
People can also hack into the code sandbox and then share it.
Yes, of course.
It would be nice to see other examples also. Like really great talk, Alfonso. What questions do we have for him?
I do have, well, first of all, thanks for the talk. It was great, and it showed a pattern I didn't think of, and I have to check more in details about the state reducer of that works and of you handle that. But I do have some doubt about this pattern, and my main doubt is, do we really want to give that much control over something? Doesn't that overcomplicate maintenance? And
yeah, so complicate maintenance is actually utterly complicated on the other end when you don't have this, because as I was showing on this example, let's say you have all of these filters, right? Then you have to add one because your client from the I don't know, the banking app that your company provides needs to filter by lower than $10, for example. Okay, and you add that here. Then comes the other guy who has to filter for over $100, and so on and so forth, and you end with a lot of functions that you have to pass. Let imagine that on an accordion, for example. Yeah. Let's imagine you have these three functions that, as you can see, you probably have an accordion that has PreventClose, right? And it will work fine because that's not a lot of props, right? But let's say then you have something that opens only when you have, you could have three tabs open, but the fourth would close the first one that you opened previously. How do you implement that and then maintain that and so on? And if you keep doing that, of course, it's a trade-off. Most thing on technology, you have to think. I am maintaining these three things, and that's fine for now. But when you have the fourth and the fifth and so on, you have to think. Well, maybe I just do that, and as you can see here, you can implement helpers that well have these things here, so your client can implement the things easily, but you also have the functionality and the maintaining overhead of a simple accord or a simple component, not only accord.
I do understand the concept behind that, but and when you are talking about a single function like the filter one, I totally agree with you that it's quite simple. But when you, in my opinion, when you go inside React and the components and the fact and all the handling of the state, and when you invert control like you showed us, you have no control over the state of your components, because the client can do anything he wants. And I do understand that sometimes it's a requirement, but you can also do something, you can do a middle ground where your accordion doesn't handle the state at all, and you can do a more generic implementation of the accordion that only handles the way you show things, and it accepts an array of open open tabs, open accordions, and the client, without having to create a reducer or anything, is just changing the array wherever he is using the component.
Yes, of course. You have multiple ways of implementing an accordion. The accordion is just an example, but the idea here is that you could provide inversion of control to the full state reducer here, or you could provide it to only let's say the change of one tab. It really depends on what you want to let your user do in the end and what you want to maintain control of. Right? So yeah, of course, you can meet everywhere in give full control to them or have full control of you can put it's a gradual thing to change, right? So you can be anywhere in that line and it would be fine. But the idea here is to have it available to you when you do need it.
I see. Yeah. Yeah. So it's not. Yeah. Okay. It's a pattern that has to be evaluated deeply because it comes with huge trades off. Okay.
Yeah. Of course. Yeah. As all of the patterns, I think you have to know when to implement it and why are you implementing that. In this case, I think it makes sense to implement one, but there are some cases that you would prefer the users to be completely logged on the functionality that you already are providing.
Okay, thank you.
Mm-hmm.
Yeah. With this, I also think that placing the state reducer directly as a prop is kind of a good way to show how much power you can give to the external. But
yep.
As you said, it could easily be that you provide some hooks or only let the people change the function that, as you said, changes handles when something changed for the tabs. So
mm-hmm.
All the examples that you show, it can just be that function that you override and nothing more.
Yep.
But it's cool to see that you can even do this. I posted a talk about that the guy from Airbnb did. That was great to see also how they started with a component that had an API of hundreds of props, let's say just a button with hundreds of props because of what you said. And then afterwards they started to do smaller, more basic building blocks and let the user build the components. Or maybe they give you some pre-built like you did, like the basic accordion, the single accordion, and these kind of things. And if the users want something else, they can, instead of you having to add another prop that is going to mess up with your bundle size and the complexity with all the branching, you can just say to him, look, I can give you the same Legos that I'm using. You can build whatever you want. And then maybe you can even help with that. But that is a very good way for keeping more or less simple the design systems. I think in dim sum, for example, you're having similar issues, no?
In some cases, there are some cases where it's done componentable components, but we have some issues in some places.
Mm-hmm.
Okay, so any more questions, or we can leave it as is. If you want to play with the accordion and do something cool, you can do it and share it with us on the channel.
Yeah, that would be great. Okay. Thanks everybody then. Thanks a lot, Alfonso. It was a great talk. And let's keep chatting then. See you all.